I think we're on right now to speak. What I've got here are a couple of questions from the assess of chapter 7, so we're assessing the presenting of data, or the representing of data rather. Looking at page 97. I've taken the liberty of doing some annotations before starting the video in order to speed things up a little bit. This is actually question 3 on page 96. The pie charts below show how 200 students travel to college on one day during winter and on one day during the summer. So I put 200 there and there, and I've underlined the one day. That's going to be a little significant later on when we come to talk about why one day only. So this is the winter lot, and this is the summer lot. Just get a slightly thinner pen, I think. There you go, about that. Okay, it says work out the angles for each method of travel for each pie chart. So I've got 8 little calculations to do. So looking at the winter ones first, I colour coded the bus red, so 3/10 of the entire pie, representing these 200 students travelled by bus. So it's 3/10 of 360, which makes 108 degrees. That's what it asks me to do. For cycling, which is a tenth of the 200, a tenth of a tenth of the 200 students are those who cycle. It asks the actual angle. So here we go. A tenth of 360 is 36. By car, we've got 9/20ths of 360, which comes out to be 162 degrees. And finally, those who walk, the 3/20ths will be 3/20ths of 360, giving us 54 degrees. Alright, so we know these all add up to 360, and it represents 200 students. Now, on this side, we're not given fractions, we're given the actual number of students who walk, who bus it, who take the car, who cycle. These add up to 200, and therefore, instead of having a fraction given to us, we need to work out our own fraction first. So look at those who bus it. We've got 39 out of the 200, so it's 39 out of 200 times the 360 gives us 70.2 degrees. Those who cycle, it's 78 out of 200 times 360 gives us 140.4 degrees. Those who use the car, 28 over 200 times 360 gives us 50.4 degrees. And last of all, those who walk, it's 55 over 200 students times 360 gives us 99 degrees. So we've done those 8 calculations, so that part is done. Again, you can just study that in your own time. We're to compare the methods of travel for the different times of year. Well, there's 4 methods of travel, so we can make 4 statements here. So judging by the angles, we can say that more people take the bus to college in the winter, alright, because 108 is a bigger chunk of the pie than 70.2. And since we know that we have 200 students in each case, we know that the bigger the angle does actually represent a greater number of students. Alright, so first statement, in the winter more people take the bus to college. This one, in the summer more people cycle to college compared to the winter. Next statement, more people take the car to college in the winter compared to the summer. And finally, more people walk to college in the summer compared with the winter. Alright, there's 4 statements, and you could have said the converse as well. Less people take the bus during the summer, less people cycle during the winter, etc. Alright, just say it one way, and if it means the same, don't go and say it around the other way as well. There's no point. It's just one mark for one statement. Alright, compare the methods. I've done it. Now Sandy, who obviously conducted this survey, said this proves more people walk to college in the summer. Well, the math says 99 degrees beats 54 degrees, so we can say yes, it does prove that more people walk to college in the summer. That's been justified. However, if you say the survey was only conducted on one day, which is why I underlined it here and here, you can say no, this data only relates to one day. To be sure of her conclusions, Sandy would need to conduct the same survey over a number of days or even a number of weeks to gather more data. Alright, so yes, she's right, because 99 beats 54, but she may not be right because she's only collected data over 1 day only. She would need to gather data over a much longer period of time, over weeks perhaps, weeks for the winter and weeks for the summer, and then she'll have a bigger picture of what's going on. Alright? Next question. Again, I've mutilated this a little bit, or prepped it, however you want to call it. The working yellow. Right, it says the heights of 40 workers in a factory are given in the diagram. Now look, this is a two-way stem and leaf diagram. We have the males going to the right, the females going to the left. Look at the girls' key, 167. How's that represented? By 716, because we go 167. Alright, so 716 is not 716, it's 167, reading that way. Alright. Now, explain why the median male height is 174.5. Now, there aren't any decimal points there, no decimal places, only whole numbers of centimetres. Now, let's take a look. I've calculated the fact there are 16 males, so if I've got 16 males, to find the median, I'd take 16 males, add on 1, divide by 2, that's 17 divided by 2. I'm looking for male number 8. Let's just lose that. I'm looking for male number 8.5. I'm looking for the 8.5 male. So let's just count up, shall we? 1, 2, 3, 4, 5, 6, 7, 8. So there's the remaining 8, making up 16. To work out the median, I've got to look right here between the 8th and the 9th. Alright? So I take my, let's do the calculation here. I've got 174 and 175 sitting in the middle. What I do is just average them out. So 174 plus 175. I know that when I divide by 2, I'm going to get the number between 174 and 175, which is clearly 174.5. Therefore, although this number is not, this height is not in the table, it is in fact correct. We've shown it there, and I've shown it. Next question says, show that about 19% of males are shorter than the median female. Well, first of all, let's find out this median female. I've got 24 females, add on 1, divide by 2. I'm looking for female number 12.5. So 12.5, here I go. Starting from the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, oh, and 12 again. I'm on that one. So female number 12.5 is right there between the 12th and the 13th, and her height is going to be 167.5 centimetres, in exactly the same way I calculated the males. Show that about 19% of the males are shorter than the median female. So let's find this height for the boys. 169, 169, 167. So those who are shorter than 167.5 are that one, and that one. So going back to yellow, I've got 3 chaps out of the 16 are shorter than the median female. So then I'm change that into a percentage by multiplying by 100. Grab my machine. So 3 divided by 16, multiply by 100. I've got an answer of 18.75%. Here I go, 18.75%, and that's approximately equal to 19%, and therefore I've proved it. Alright? It says here, compare the ranges of the female and male heights, or male and female heights. Okay, let's just do the ranges down here. Let's do the females. Biggest takeaway, smallest. The tallest female is 182. There she is. There's no data in the 190s for females. So 182, take away the shortest, 149. And that will give us, quick machine, 182, take away 149, that gives us 33, so we have a range of 33 centimeters, or a spread of 33 centimeters. Now we're going to do the boys. The tallest chap is 191 centimeters, quite tall, and the shortest chap is 162 centimeters. Let's just do that one. 191 minus 162, and we're getting a spread of 29 centimeters. So I've done the maths. Now let's prove to the examiner we know what we're chatting about. Compare the ranges of male and females. Okay, just doing the calculation alone does not compare any range at all. You have to make a statement. I can say straight away that there is a greater variation in the heights of females compared with males. I can say there is a greater spread of heights amongst the females than the males, or I can say the converse. There is a narrower spread of heights amongst the males compared with females. There is a narrower spread of heights amongst the males, and that's it. Alright, so any of those statements will be fine, and that question's done. Next bit. Right, again I've taken the liberty of annotating some of this question in order to save time. The bar chart shows the number of men and women visiting a dentist in 1 week. The bar for women on Friday is missing. As you can see, I've coloured it there. I've sort of gone red to represent like the red on the women, and blue for the boys. So here we go. The frequencies are shown. Okay, how many women visited the dentist on Tuesday? Well, I've already done that. Tuesday goes up to 19 for the girls. It's working in the red. So 19 for the girls. How many men and women in total visited the dentist on Monday? Well, that's going to be the 18 plus the 11. That will give us 29. So 29 visited, because I've just added up those two bars there, haven't I? Now, during the week, equal numbers of men and women visited the dentist. How many women visited the dentist on Friday? Well, had they not told us that, it would have been impossible to work out. Let's work out the men first. Working in yellow. Let's do the men. The total of all the men is 18, 15, 23, 11 and 21. Well, that will give us, let's do that quickly, 18 and 15 and 23 and 11 and 21. That gives us 88 men who went to the dentist. Aren't they brave? Now let's just do the women so far. Alright, so we've got Monday's 11. We've got, just write it down, we've got 11 plus 15, sorry, not 15, plus 19. 11 plus 19 plus 17 plus 26. Let's just do that. 11, 19, 17, 26. So we have 73 women who went to the dentist from Monday to Thursday. And if we have equal numbers of men and women who went, if I take it away, I'm going to find how many leftovers I've got, and these will be the women who went to the dentist on Friday. So I'm going to do 88 take away 73. That's going to give me 15 women who went to the dentist on the Friday. And I assure you, putting the bar up to 15 was a complete fluke. I didn't know what the answer was, and I'm quite happy with that because it looks quite good. So how many went to dentist on the Friday? I can now write it in as 15, and there it goes. It happens to be 15 there, and that's really nice. I'm signing off topic, what do you call it? I'm signing off topic 7. I'm happy enough with that, and we're done. A little signature there will be fine. Alright.